Hi everyone, in this video we'll be seeing some of the Spark streaming concepts. The first one is transformations, then we will see actions. We will also see what are the supported sources and then what are the supported sinks and what are the available modes in Spark structured streaming. So first of all, let's understand about the transformations. So what exactly are transformations? So you can imagine transformations are like the functions that operate on existing datasets and to create new datasets. Now, when I say datasets, don't get confused by the Spark dataset, data frame, or RDD thing. Datasets means you have some data and you applied some transformation, let's say function on top of it, and a new dataset is created or a new data is created. Then you again applied a new function or transformation, and again a new dataset is created. Now, so there are a couple of points here. So they are designed to be lazy. Lazy means, let's say this was our original data set or data D1, this is D2, and this is D3. Now let's say you applied the transformation fn1 and then you apply the transformation fn2, so they won't be invoked immediately, and from d1 to d3 won't be immediately calculated. It will be executed only when the action is triggered. Now what exactly is an action, that we will see in the next section. So just remember that while we are applying the functions or the transformations, they are lazy, they do not get immediately executed. Some of the transformations are map and filter. So map is like, let's say you have a list and you have some records and you have a function which is map function, and so the map function takes in each element, applies the logic, and creates another element. So if there are four elements, the map function will create four results. The filter is generally used for cutting down the data. So if you have four records, maybe if you apply a filter transformation, the resulting data set will contain less number of records than the original data source. Alright, so this is about transformation. Let's see an example. I started this Spark shell, that is why this UI was launched. Now let us do read some data. So I have some code with me, so I will run up to this. Now I'm reading some data. Now let's say we want to print the schema. So there are three columns here. One is, for the first one is ID, then event time, then clicked resource. So there is no job, no stages, nothing is there, right? So let us do some kind of transformation. I have copied this statement and I will paste it on the terminal. Okay, so now I have created another data frame from the existing data frame. Let's go to the Spark UI to see what is happening there. So nothing is happening there, which means that these are all transformations. So you had the initial data frame df and you applied some transformation on top of it, like df.where. This is a filter transformation kind of. Now there nothing is being executed right now. So only once when you do an action, let's say df.count, then if you go to Spark UI and see, then you have jobs. So whenever you trigger an action, then only the job will be created in the Spark UI. Now, if you go to the stages, you will see there are two stages. So the 0.4 second and this one. So one of one is skipped, means Spark doesn't Spark did not want to evaluate this, and it can skip this stages because it can read from the cache itself. So if you see this tag visualization here, so there is an exchange here. This is skipped because it was already evaluated, so Spark doesn't want to evaluate it again. So that is why it is skipped. So we just did a count operation, and the count operation is an action, and that's why the all of the transformation, whatever transformation you will apply on the existing data sets, those will be executed. That is it for the transformation, I believe. So let us understand what are actions in Spark. So actions in Spark can be considered as operations which are actually returning some result to the Spark driver program. Or let's say the data is getting written to the some external storage system. Now the action, So action are those functions actually that trigger the scheduler, and this scheduler builds a DAG. So DAG is short for directed acyclic graph. There is no cycle in that. That is why it is called acyclic. There are some common actions which are count and collect that are used to return some result to the Spark driver program. So as I was discussing previously about the example, let's open that. So now we had a data frame, right? Filter data frame. Let's say you want to see the filter data frame. So we will see filter data frame dot show. So now, so the original data frame, if you see, it had a lot of other data also for the clicked resource. If you remember, for the filter data frame, we said okay, click another data frame where clicked resource equal to add to cart. So now show is an action which actually triggered the flow, and then all of the transformations were executed and the results are visible here. So if you go to the Spark UI and refresh it, so just now we did a show, so this is for that. If you click on this, so you can see the DAG visualization here. Alright, so generally an action is something that will create one job here at least. Alright, in the Spark UI you can validate that. If you want to understand more about the DAG in Apache Spark, I had written an article sometime back on July 15, 2023, and a lot of people read that. And if you want to have a good idea about what is DAG in Apache Spark, I will suggest go through it and let me know in the comments if you have any question. So what I will do is I'll put this link in the video's comment section in the YouTube, and you can open it from there. That's it for the actions in Apache Spark. Although in Spark Structured Streaming, we will mostly use one action which is called start. That is for starting the streams. So generally, all lot of other actions won't be applied in the structured streaming world. Mostly we will be using only one kind of action, like which is start. Let's understand about the sources that are available in Spark Structured Streaming. So the first one is file. So let's say you have a folder and the files are coming in like f1, f2, f3. These are coming in constantly one by one in this folder. So Spark has the capability to read the files that and it reads the file in order that they were last changed. So some of the supported files are CSV, JSON and ORC Parquet file formats. The second one is Kafka. So we have a Kafka topic, and Spark can read from the Kafka topic, and you can do some processing and then write the result to some kind of sinks. So a lot of organizations use Kafka as their sources for Spark structured streaming. The third one is Socket, and also the fourth one is Rate. Socket and Rate are mostly used for testing. So Socket is something, let's say you have created a connection to a socket connection to port 9999 on some host, and then there will be a terminal, and you are printing some messages, you are writing some messages and pressing enter. So all of these messages, whatever you are typing, can be captured by Spark, and whatever action you want to take, you can take on those messages. So basically it is only for testing purpose and should not be used in the production systems. Now the fourth one is Rate. Rate is something, let's say you can say that okay, I want to generate the records at a particular rate per second, let's say 10 records per second, 10 records per second, and this particular record will contain the timestamp and the count starting from 0. So this is mostly used for testing and benchmarking, because you can increase the number from 10 to 100 and see how your Spark job is performing, how your Spark structured streaming job is performing. You can increase to 1000 and see how it is performing. So that is why it is mostly used for testing and benchmarking. Now let us understand about the supported sinks or the destinations in Apache Spark structured streaming. The first one is file. So it is as simple as that whatever output you want to store, you can store in an output directory. The second one is Kafka, which is mostly used by many organizations. So your source can be Kafka, your processing engine can be Spark, and then your sink can also be Kafka. or your source can be something else, let's say file source, and your processing engine is Spark, and then your destination or sink can be Kafka. So a lot of organizations use Kafka as the sink if they want to take further processing. Now for each and for each batch are, can allow you to do some kind of arbitrary operations and writing logic on the output of a streaming query. Now imagine for each batch is like this. So there is a for each batch, and whatever action you want to perform, you can run multiple statements in that. You can save it. Let's say you can save the result to a disk. You can save the result to Kafka. You can save the result to some kind of other external system. Whatever action you want to take, you can take using for each and for each batch. Console is again for only testing purpose, because it will be just printing the messages to the std out, or the console. Memory is something, let's say whatever output you are generating, that will be stored as in memory table, and you can run some query on top of that, run queries on top of that, and mostly used for debugging purpose. So mostly for production systems, I have seen the Kafka and for each batch, a combination of this are mostly used for the production systems. Now let us understand about the output modes in Apache Spark Structured Streaming. So the first one is complete. So complete means the entire updated result table will be written to the external storage. Now result table is the intermediate or in-memory table which is constantly getting updated. So let's take an example here. So these are three different times. So this is T1, this is T2, and this is T3. Let's say at time T1 some of the records came like cat, dog, dog, dog. So if you are doing a word count operation on top of that, so what will happen at the T1 time? So cat is 1 and dog is 3. Alright, so if you are using output mode as complete, it will print all of the result like this, cat 1 and dog 3. Now at time T2 another two records came, which is owl and cat, two different words. Now if you see, cat is 2, dog is 3, and owl is 1. Now previously it had cat 1 and dog 3. Now cat is increased by 1, dog did not increase, and then owl is 1 times. So it is remembering the previous result, which is cat 1 dog 3, and adding whatever words came, it is adding on top of the previous result. So for the complete output mode, all of the results will be written to the sink. Imagine at time t3 dog and owl two words came. Now at time t3 if you see, cat is 2, cat remains 2, dog is 3, dog becomes 4 because of this one, and owl is 1, owl becomes 2 because of this one. Now this is the complete output. Now this complete output will be written to the sink. Now what did you observe at time t1, at time t2, and at time t3? So all of the results of the previous computation are getting added, and all of those results are getting written to the sink. So sometimes the results are updated, sometimes the results are the same. In this case dog 3 was there already written to the sink. Again dog did not change, but again dog 3 was written to the sink. Now cat 2 was written to the sink at time t2. Again cat 2 got written to the at time t3 to the sink. And obviously the dog and owl changed, so they have updated value. So this is taking extra space, right? Because every time the previous results are also getting written, correct, right? So extra space is required for the complete output mode. So this is an example for the complete output mode. Now let us understand about the append output mode. So it says that only the new rows appended in the result table since the last trigger will be written to the external storage. So what happens as I already discussed with you, like Spark is a micro batching system. So there are triggers. You can define an interval of the triggers. Let's say every 5 seconds Spark will go and read from the Kafka topics. A bunch of records will be read and then processed, and the result will be sent to the sink. Again, if the 5 seconds of trigger interval expires, it will again go and read the data, again do the processing like that. So let's take an example. Let's say there is a website and some users are getting there and they are registering their information on the website. So we want to stream those information to Kafka topics and then capture those events from the Kafka topics and put those information to some kind of a sink, let's say some table. Now what we can do is use the append mode. So let's say in first trigger the two records were there, so Spark read both of these, and then it actually used the append mode and wrote the data to some kind of a sink or the table which we discussed. So in the next trigger, it will again read the couple of records here, which is C and D, and then it will be writing the results to the sink. Now A and B won't be written again, because complete mode, if you remember, all of the data was getting written again and again. But here, since A and B records are already written, they won't be written again. The new records in this trigger C and D will be written to the sink. So there is no aggregation here, but if you want to do an aggregation, you will have to use the watermarking concept, because without watermarking it won't allow you to do aggregations in append mode. Now let us talk about the update output mode. So it says that only the rows that were updated in the result table is the intermediate table, since the last trigger will be written to the external storage. The second point is, if our query doesn't have any aggregation, it is kind of like an append mode only. So let's take an example here. Let's say we have a website, and if you remember our clickstream example, where we want to, let's say, understand about the user engagements. Impression is something, let's say user is visiting a page, opened a page, that is one impression for him. So here in this case, let's say we have two records coming in. These are aggregated. So user A has two impressions, user B has one impression, and the Spark Streaming is reading this from the Kafka topic, and now we are using update output mode. So it will write the result to the sink. Alright, let's say we have another batch, and in that we saw that A has one impression and B doesn't have any impression, and D has four impressions. Alright, so what will happen in this case? The result table will look like this. This is the result table, this one below one. So it will, after aggregation, the intermediate result will look like this. So A was 2 previously, now A, one more impression came, so A became 3 and D is 4 here. There is no B, so this is our result table, intermediate result table, and this will be written to the sink. Now if you understood the difference here, in append mode only the new records were getting written, but in this one, the update mode, the previous record also, which we have already seen, if that is updated, then only it will be written to the sink. Since we did not see the event B, the B will not be written to the sink. So only A3, D4, these two records will be written to the sink. This is in update output mode. And this is very important point. If there is no any aggregation, it will be just like the append mode. Alright. So here you can see the summary of the output modes. Let's revisit them once again. So in append mode, only the new rows appended in the result table, since the last trigger, will be written to the external storage. In update mode, the rows that were updated since the last trigger will be written to the external storage. If your query doesn't contain aggregations, it will be like the append mode. In the complete mode, the entire updated result table will be written to the external storage. So that's it for this video, guys. If you really like this video, don't forget to give a thumbs up. Happy learning.